In this video, we're going to talk about the last thing that must be true about a function in order for it to be differentiable. And that's that it must be continuous. I wrote this, a function must be continuous to be differentiable, but it must be continuous at a point to be differentiable at that point. So this function is very much differentiable at all these points over here. You can just see it's the tangent line. You get the tangent line, you take the slope of it, you found the derivative. And then if you were to go up, all the way up to this part of the function, you can see again very clearly. The problem comes right from here, and this comes from the idea that we talked about also with the cusp. If you look as you approach 2 from the right, this derivative, the slope, is getting closer and closer and closer to 0. And if you actually hit 2, you would get a slope of 0 from the right. As you approach it from the left, you can see that you have a negative number. I'm not exactly sure what it is, but it's definitely not 0. If anything, it's heading towards no slope, but definitely not heading to be a horizontal line. So right exactly at 2, if I can get my cursor to go there for a moment, you can see that as you approach from the right, the slope is heading to 0. And as you approach from the left, the slope is heading to some negative number that's most absolutely not 0. And since the two limits don't agree when the function is not continuous, therefore it's not differentiable at the point. So this function is not differentiable when x equals 2. That doesn't mean it's not differentiable everywhere else. But in order to be differentiable, it must be continuous. Just because it's continuous doesn't mean it's differentiable, but if it's differentiable, then it must have been continuous at that point.